Assalamualaikum and hi everyone. My name is Rosin Sahira and I'm from Group 13. And this group will be discussing about water treatment in electrochemistry. So, you guys must be wondering, what is water treatment in electrochemistry? Water treatment is a process of purifying water to make it suitable for consumption, industrial use, or returning to environment. Because there are a substance in water that can harm us or animals and plants if we consume it, such as pathogens, organic particles, soluble organic materials, inorganic particles, soluble inorganic material, animals, macrosolids, gases, emulsions, and toxins. Water treatment is related to the physical-chemical treatment method. It characterized by multi-stage and relative complexity of physical and chemical phenomena occurring in electrochemical reactors, which is electrolyzers. Its rate of occurrence of the individual reaction steps are depend on many factors. Basically, we have three methods in electrochemical water treatment. First of all, it's conversion method, which is electrochemical destruction, electro-oxidation, and electro-reduction. Other than that, we have separation method, which is electroflotation, electrodialysis, electrodeposition, electrofiltration, and electrodeionization. Lastly, we have a combined method, electrocoagulation, electrophotocoagulation, electrocatalysis, electrodisinfection, electrophoton process, photoelectrocatalysis, and sonoelectrocatalysis. But my group mate will be focused one or two for each method. So that's all for me, and I will pass to Balkis to talk about the conversion method.
Hi, my name is Balkis. So I will be talking about conversion method. What is conversion method? It is change of physical, chemical, and phase characteristics of dispersed pollutant in regard to the neutralization, conversion, and removal from the wastewater. Our main focus for conversion method is electrooxidation. Electrooxidation used in water treatment from dissolved impurities. For example, cyanide, thiocyanides, amines, alcohol, aldehydes, and sulfide. Electrooxidation uses an external energy source to remove organic pollutant from wastewater. It is an effective method to remove wide range of pollutants. Electrooxidation have two mechanisms. The first one is direct electrooxidation. Direct electrooxidation involves the contribution of electrons which oxidize the contaminants molecules, resulting in direct charge transfer reaction, mainly controlled by molecules transport and electron transfer rate at net interface. The advantages of direct electrooxidation is no need for additional chemicals. For the second mechanism of electrooxidation is indirect electrooxidation, which uses the intermediation of strong oxidant reagent. Strong oxidant generated on the inert surface act as electron carriers between inert and organic contaminant in bulk phase. So, it's resulting in the organic degradation of molecules. The advantages for indirect electrooxidation is preventing electrode passivation and enhancing electrocatalytic activity. And that's all from me. Now I will pass for the second method to Dini.
Hi, my name is Dini Nadra binti Ahmad Sahari. So now I'm gonna talk about separation method. What is separation method? It is techniques that use electrochemical principles in separating dissolved and suspended impurities from water. The significance of the method is that it applies electric potential and electrodes to drive the movement and changes in the particles and ions. Besides, this technique separates suspended solids, dissolved ions, and even microorganisms from water. There are several separation method techniques, including electroflotation, electrodialysis, electrodeposition, electrofiltration, and electrodeionization. Why we need to use separation method? It provides high removal efficiency without any chemical addition. It reduces the amount of chemical waste and prevents total environmental damage, and is applicable in all varieties of contaminants from salts to suspended solids and oils. So now, I will be more focused to electrodeposition. So what is electrodeposition? Electrodeposition is a process where dissolved metals in water are separated by depositing them on an electrode with the help of an electric current. So, if you guys want to know how actually we created electrodeposition using electrochemical cells, so it actually consists of two conductive or semiconductive electrodes that immerse in an electrolyte. So basically, we need to have one cathode and one anode that immerse in electrolyte. So, how it works? The metal ions in the electrolyte solution are reduced at the cathode to form a solid metal layer. These metal ions are from the solution containing metals that are to be removed or recovered. So, you guys can see these two pictures are visualize all the things that I see just now. Next, the application that we can apply electrodeposition in our life. The first one is removing heavy metals from wastewater, recovering valuable metals like gold, silver or copper, and lastly, electroplating to coat materials with a layer of metal. So now, I'm gonna pass this slide to Nur Afika to continue.
Hello, so now for other separation method we are going to discuss is electrodeionization, EDI. EDI, which also known as continuous deionization, CDI, is a hybrid separation process consisting of electrodialysis and ion exchange methods. Its primary purpose is the removal and recovery of ions from water to achieve ultra-pure water standards. What sets EDI apart is its ability to operate continuously without requiring chemical regenerants, making it an environmentally friendly alternative compared to the traditional methods. EDI system function when cation and anion exchange membranes are placed between the electrodes like an electrodialysis system. The central compartment is filled with ion exchange materials that enhance the transport of cations or anions under the driving force of a direct current. Direct current power is applied to a positive electrode, which is anode, located on one end of the module, and to a negative electrode, which is a cathode, located on the other end. Water dissociation reaction during EDI operation produces hydrogen, H+, and hydroxyl ions, OH-, which continuously regenerate the ion exchange resins electrochemically without using regenerating chemicals. This innovative electro regeneration eliminates the need for chemical regenerants and provides a consistent deionization process. EDI is highly effective due to several key features and benefits. First, it achieves deep deionization, removing ions to extremely low levels, making it ideal for producing ultra-pure water for industrial applications. Second, it is environmentally friendly, as it does not require chemicals for resin regeneration. Instead, it uses an electric field to sustain the process. Additionally, EDI is energy efficient with electricity consumption ranging between 0.2 to 3 kilowatt-hour per 1,000 gallons of product water, depending on feedwater quality and system design. EDI has a wide range of applications, such as ultra-pure water production, which is essential for semiconductors, pharmaceuticals, and power plants. In semiconductor manufacturing, ultra-pure water is critical for rinsing silicon wafers to prevent contamination during chip fabrication. In the pharmaceutical industry, EDI ensures water complies with strict standards for water for injection and clean-in-place CIP applications. Power plants also depend on ultra-pure water produced by EDI to prevent scale and corrosion in turbines, ensuring efficient and reliable operations. And that's all for separation methods. Next presenter will be Nurul Fazila binti Abdul Rafiq. Thank you.
Hello everyone, my name is Nurul Fazila binti Abdul Rafiq. I'll be taking part in the last method, which is the combine method. Our group chose the electrocoagulation process as our main focus under the combine method for this assignment. Now, let us see what is the electrocoagulation process. Electrocoagulation is a process that uses electric current and electrode to remove the impurities in the process of water treatment. According to Faraday's law, when direct current flows through electrolyte solution, chemical reaction will happen on the surface of the electrode. First of all, anode will undergo oxidation process. Metal ions such as aluminium 3+ will be oxidized and scattered into the water. Simultaneously, hydrogen gas and hydroxide ion are released at the cathode, which undergoes reduction process. Electron flows from anode to cathode. Metal ion will react with hydroxide ions, forming metal hydroxide, which act like a magnet that will attract the impurities present in water, forming flux by neutralizing charge of the suspended particle. As we can see, this is the picture of how the electrocoagulation process occurs in the presence of water. Since cathode produce hydrogen gas, this flux then lifted up by the produced hydrogen gas and raised to the surface, which is called as the flotation process. This flux can be removed by skimming process if they float, settling if they sink, and filtration to capture residual particle. Lastly, the treated water now free of contaminants is discharged or subjected to additional treatment if necessary. Now, I'll pass the next part to Farisha.
Hi guys, my name is Farisha Alia, and now it is my part to explain about the pros and cons of electrocoagulation. So the first pros of electrocoagulation is it has low operating and maintenance costs. Secondly, it is highly automated, user-friendly treatment system with remote monitoring available. Thirdly, it can remove multiple contaminants in one pass. Other than that, it usually avoids excess use of chemicals, so it would be less harmful for us as a consumer. Next, it shows consistent treatment performance regardless of a change in water quality. Lastly, it forms very little non-hazardous and easy to dewater sludge. Okay, now let's take a look for the cons of electrocoagulation. So the first cons is it is not a passive system, so it requires power. Secondly, regular cleaning and maintenance of the electrodes is needed. Next, electrodes need to be replaced over time due to the consumption. Lastly, compared to the other treatment processes, it can require the addition of acid and bases for pH adjustment. The conclusion is the application of electrochemistry in water treatment represents a transformative approach to addressing global water quality challenges. Techniques such as electrocoagulation, electrooxidation, and electrodeposition have proven effective in removing contaminants, degrading pollutants, and disinfecting water with precision and efficiency. These methods offer sustainable and eco-friendly solution by minimizing chemical usage and energy consumption, making them suitable for diverse settings, including industrial wastewater treatment and potable water purification. Ultimately, the integration of electrochemical methods in water treatment is important for ensuring clean and safe water resources for a growing global population. That's the end of our presentation. Hope you guys gain some knowledge about the application of electrochemistry in water treatment. Thanks for watching.